1 Statics, example 5. We're getting on to slightly more complicated scenarios here, so it's really crucial to read the wording of the question really clearly and carefully and think about the implications of all the words. So we've got a smooth bead. This is the smooth bead here in the diagram. Smooth means there's no friction, so we don't need to worry about the friction between the bead and this string that it is threaded onto. The fact that the string is light and inextensible tells us that the tension will be the same throughout the string. And that's something that's given in chapter 1 of the textbook, where all the modelling assumptions are discussed. So you need to be aware that the words light and inextensible tell us that we've got a constant tension throughout the string. It tells us that the ends of the string are attached to fixed points, X and Z, on the same horizontal level. So if you imagine two ends of a string, say attached to the ceiling, and then this bead is being held, not hanging in the middle, how we would expect it to hang, but it's actually being pulled over to one side by a horizontal force. So imagine someone pulling the bead slightly to the left. The bead is vertically below X, and we've got an angle of 30 degrees over here. So we've got to label all the forces on the diagram to start off with. So remember, the tension is the same throughout the string. So there'll be a tension holding the bead up in that direction, and there'll be a tension wanting to make it move over to the right hand side on that side of the bead. So it's smoothly threaded onto this string, meaning the tension's the same on both sides. We've got our 8 to the left. And remember, because it's being held in a vertical plane, we've also got the weight. Now, we don't know the actual mass of this object, this bead. In fact, that's one of the things that we've been asked to find out over here. So I'll just call it W, weight, and that's what we're going to be asked to find out. So the first thing, we've got to find the tension in the string. Now, you need to make a decision about whether to resolve vertically or horizontally. I'm looking at this situation, and I'm thinking if I resolve vertically, I'm going to be involving W, the weight. We don't know W yet, that's part B. So that leads me to make the decision that I'm going to resolve horizontally. So now this T here will have a component horizontally, and it will be turning through an angle, but we need to be clear on what that angle is. Now, if you remember from year 7, when you were doing basic angle work, you might remember that this angle and this angle are equal. If that was 30 degrees, this would be 30 degrees. If you remember, they are called, you might want to say Z angles, but let's try and use the correct name. They are called alternate angles. So if this angle here is 30, then this angle here will also be 30. They're alternate angles. So those basic angle properties you are expected to remember from year 7 and 8 and through to GCSE. So resolving to the right will now be T cos of 30. That's the only force that has a component to the right. And to the left, we've got a component 8. So it's really straightforward, just divide through. T is 8 divided by cos of 30. Working that out gives us 9.24 to 3SF. Again, keep that full value in the calculator. We now need to find the weight of the bead. We're going to be resolving vertically. So we've got T upwards. We've also got this other T, which is the same value, but it's going to be resolved, and it's going to be T sine of 30, and resolve it. So they're upwards, and the weight is downwards. Okay, so using your value of T that you've got in part A, substitute it in, and when I did it, I worked out that it was 13.9 something. I haven't actually used the value of G in this question, so I think I'm okay giving answers to 3 significant figures.